Okay, so in this one, I want to derive the inverse sine, inverse cosine, and inverse tangent graphs. And what I'm going to do is sort of weird at first. So inverse sine, if y equals sine of x, and that's graphed over here on the left. If y equals sine of x, then the inverse relation is x equals sine of y. That doesn't guarantee that it's a function, but it does guarantee that these guys are inverses of each other. So if I were to graph x equals sine y, remember that's the same thing as just switching all the x's and y's. So you could kind of think of it as if this was the x-axis and the y-axis, well, let's just make this the x-axis and this the y-axis. Then if I spin the entire thing 90 degrees counterclockwise, I've got the y-axis pointing up the right way, but the x-axis is actually backwards. So it would look it would look like this right now. If you spin this around like that. Can you guys picture that? So here's the x in the positive direction is going backwards and y is up here. So this graph would look like, let's see, this part right here would be sticking out right there, and then this part here would be sticking out right here, and then it would just keep going like this, right? But again, we don't really want the x-axis pointing in the wrong direction, so we'd want to flip everything over so that the x-axis is pointing in the right direction. So if I did that, well, that's just going to flip this graph around. So I'll do that in a different color and then erase the red. So that would be this instead. Right? So let me get rid of this and that and this. So now our x is actually pointing in the correct direction. And what I've graphed here in green is the graph of sine of y equals x, which is the inverse of y equals sine of x. And some points on this graph would be that 0, 0 right there. This point right here is really going to be 1 comma pi over 2, not pi over 2 comma 1, right? Because I've switched them. This point right here is going to be negative 1 comma negative pi over 2. Now the problem with trying to use this as sine inverse is that it's not a function, right? Because it fails the vertical line test. I'm talking about this graph over here. Fails the vertical line test. So this green graph is not a function. So what happens is that people have defined this thing a specific way to force it to be a function. So you actually ignore a ton of the graph. So in order to make it a function, people have just decided we're just going to look at this right here and get rid of all this and get rid of all this. And this curve that's right in there is going to be called sine inverse. And so this right here, this curve is sine inverse of x. And it's got domain restrictions, right? So the domain is the range of sine, which is negative 1 to 1. And it's got range, really the range is what's restricted here because it's not going from negative infinity to infinity like the original green picture suggests. It's really just going from negative pi over 2 to pi over 2. And that's why when you do sine inverse of some number, you only get answers that are going to be in these two quadrants, either negative, anything from negative 90 degrees up to 90 degrees, right? That's why it's here, because of this restriction. Okay, so scrolling down, if we do the same sort of deal with cosine, if you flip around the graph, so right now this is x and y, and if I rotate them and make the inverse, y equals cosine x instead, or whoops, x equals cosine y instead, that's like switching the axes. So this becomes the y and this becomes the x-axis. I can spin it around and then I get this picture where here, this bulge right here ends up here, and then it curves around like this over and over again, right? But then I need the x-axis pointing in the correct direction. So I really need it pointing this way. So I'm going to flip the whole graph around like that. So when I flip that whole graph around, I'll graph this in red. Then I get this graph instead. And this graph is not one-to-one either. That red graph, again, is not a function because it doesn't pass the vertical line test either. And so let's label a few important points, like this point right here. Whoops, let me get rid of that. So this point here, instead of being 0, 1, is now 1, 0. This point here is like this one down here. That's at pi 0 on our original graph, so, oh no, wait, sorry, pi negative 1. So on our new graph, it's at negative 1 pi. This one would be at negative 1 negative pi. These 2 points right here would be at, let's see, x is 0 for both of those, and this one's negative pi over 2. And here it's 0, and it's pi over 2. Now the problem with this is it doesn't pass the vertical line test, but one region of it that does is this region right here. Right? So we can take that region and define that to be a cosine inverse function. And then that forces it to be a function because it does pass the vertical line test. So cosine inverse of x is really just this little window right there. And its domain is from negative 1 to 1, just like the range over here. And the range is going to be from 0 to pi. Okay. I'm going to stop right there. I'll do tan inverse on a separate video.